Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Zulqarnain bin Muthaza. Today I would like to present about my project. My title project is Thermal Analysis of Transformer in Substation within in Transformer Material Selection. Before that, I want to thank to my supervisor, Dr. TST Sim Ying, for help me for complete successful this project. Okay, for the abstract, the thermal performance of power substation is major topic. Actually, for the heat temperature of the transformer begin. So, more efficient transformer have a lower temperature rise, whereas less efficient unit have a higher temperature rise. Thermal method analysis, which is the simulation software by using SolidWorks, was used to evaluate the thermal performance. Okay, from the simulation between atmosphere metal and atmosphere steel, uh, the result will show the comparison in graph, which is temperature, heat flux, and thermal conductivity that show to suitable material core transformer. Introduction. For introduction, I would like to say the transformer solution is electrical system that contain the distribution and transmission line termination as well as switchgear. The heat created during transformer operation rise the temperature of the temperature initial structure. So the surface of the transformer will be heat do the operation running. So the more efficient transformer have a lower temperature rise. So the problem statement of my project is low resistant copper used for winding remain the resistant and cause a heat loss. Second, the thermal radiation produced by a transformer exists the lower limit the operating efficient of transformer. For my objective for to my project is I want to study and compare transformer material in substation that contribute to the thermal problem, which is my I study on core transformer material, and I developed the simulation modeling for to do the thermal analysis, which is I use the SolidWorks simulation, and then I propose the suitable transformer material based on the analysis result. From the scope, project this project is focused on identify the material that may cause the thermal problem at the substation. By using the SolidWorks software, simulation testing on the thermal process can be done with the same parameter from the miniature. So the all parameter that I use for my simulation is I get from my site visit, which is to help me to get uh, the exactly what the same heat get from the actual on the site project. Okay, for the methodology, from figure 1 show the flowchart project within my flow progress for this project. For a literature review for the objective 1, I study the material based on research study for before. And the selection transformer, I go site on Malaysia Marine Engineer and Heavy at the Pasir Gudang for see the what type of transformer that you use. And detail of transformer, the detail transformer is a parameter that use for this simulation. After that, material core, which is I want to compare two material, which is metal and steel. Second, I go to simulation. Simulation, as you want to see in figure 2, this is my 3D modeling by using SolidWorks. So this one is core material, and if the simulation is good and the graph was uh, uh, was get from as actual the get, so result analysis will be out. And from the result from two material, I will compare the graph in I will do the analysis. Then lastly, all the analysis will be in the report. Okay, on a figure 3, this one is mesh modeling. Before we run the simulation, the this part we call it core part and winding part will be meshed to make sure the all part that I design is will be the running and contribute. Okay, we'll go to the result part. As you want to say, this one is metal. Figure 4 is metal and figure 5 is steel. So from two picture that we know that we can see the different color that that out that we show, because this one is we can get this is the temperature. From the temperature we can see the metal temperature on this leg core on the winding is more heat, or or the temperature rise on height side is on the winding only, but on the steel the surface the all surface will get the same temperature, which is the voltage temperature, and the voltage of the temperature will allow the surface of core is same. Okay, on figure 6 and figure 7 is we can see the flux. Heat flux determine the what how the how the energy of the winding flow to the surface. As you can see, I already circled the area that starting heat thermal. As you can see, the metal start from the middle of the leg, but the steel is only starting change the light blue color on the right and left and right limb of core. So as the four result on the picture, we can go through the graph. Okay, for the temperature graph, we can see this the line blue is the metal and the right line is the steel. As I show the graph comparison between two material, which is atmosphere daylight, and the blue is the metal. This atmosphere steel core offer the lowest than the another metal core that is when the higher temperature. But as you can see, the starting for metal is from uh, 35 degree, and faster respond until the 16 degree, they faster than the steel, because the steel on the initial time is already in 45, but slowly reaction go to 16 is take a time. Next, I will show the figure 9 heat flux vs time. As you want to say, the variation of the heat transfer in the metal blue, you can see this blue, and this interface under the heat flow initial large, it rapidly reduce with time. You can see they slowly reduce with time. On the 6 watt per meter square, we is the stabilized as a result of get air that form owning the to the metal. Compared to the steel on the red line has a modest reduce until he reached the 2 watt per meter square. It's not suitable uh, for energy, and he have a loss of energy. Second, the third one is figure 10. Figure 10, I want to show a graph about thermal conductivity and temperature. As I want to see this from this figure. This one is metal and the steel. To ability to conduct heat described by the thermal quality, the material on the black line, or we call it metal, atmosphere metal, increase with the rising temperature up to 40 degree, and increase to 60 degree as a shown in figure. As want to see, the thermal conductivity is meaning of the surface of reaction in the two material. And as I want to say the material of metal is more react to the surface heat flow better than the steel, because the metal substation have a different substation on the steel, but the metal is the pure metal substation. Okay, on the table one, we are conclude all the result to make sure the what material are suitable for the core transformer. For metal and steel, temperature rise is, I want to say, the fast reaction, and the steel is slow reaction based on the graph given. And heat flux, slow on heat transfer, and another one is high transfer heat surface. Okay, this one still good in heat flux, but on the thermal conductivity, the still have a high conductivity, and the metal have a high conductivity, but still have a low conductivity. As a conclude, from this result and the comparison of two material, I will say the emulsion metal uh, is a good material, a good material for the core transformer, reading the thermal analysis.